Good morning everyone. I am Malati from the Department of Mathematics, SNS College of Engineering. Today I am going to take the topic is graph. In that, first of all, I want to say the introduction of graph. What is a graph? What is vertex? What is edges? What is component? That are all the things I want to explain now. First one is I want to say what is a graph. Graph is nothing but the pair of vertex and edges. We can denote vertex by the letter V and the edge by the letter E. Then we can write V equal to V of G. That meaning is set of vertices. In this graph we are having here V, W, Y, Z, U, X. That are all the set of vertex. Like the same way capital E equal to E of G. That is set of edges. So we can mention the set of vertex and set of edges by V of G and E of G. The example we can write from the graph V equal to S, U, V, W, X, Y, Z and edges equal to XS, XV, XV, XU, VW, SW, SU, SV, SY, WY, UY, UZ and YZ. Edges means an edge may be labeled by a pair of vertices. For instance, we can say E equal to V comma W. So this edge is paired by the vertex V and W. Always the one edge always paired by two vertex. E is said to be an incident on V and W. Isolated vertex, a vertex without incident edge is called isolated vertex. That meaning is that vertex should be alone. From that we never get any incident vertex. Next one is special edges. We are having two types of special edges. One is parallel edges, another one is loop. Parallel edges means from the two vertex A to B, again we are having another one edge, that is called parallel edges. Two or more edges joining a pair of vertices. In example, A and B are joined by two parallel edges. Like the same way, another one special edge is loop, an edge that start and ends at the same vertex. In the example, vertex D has a loop, that is starting point and ending point at the same place. So these are all called the special edges. Next one is special graph. First one is simple graph. In the simple graphs, we doesn't have any parallel edges or any loop. So we will have exactly one edge between two vertices. So this is called simple graph. Next, weighted graph. A graph where each edge is assigned a numerical label or weight is called the weighted graph. See, for example, we can say between V1 and V2 we have mentioned that edge name as 4. So these are all the edges called weighted graph. Next one is directed graph. Directed graph means in a simple graph or undirected graph it doesn't mention any directions. That meaning is that edge we can incident from vertex A or vertex B. For directed graph it should contain a direction from where it is incident. So G is a directed graph or digraph if each edge has been associated with an ordered pair of vertices. Each edge has direction. For example, from the graph we can say here A to B, B to D, D to C, C to E, E to D. So we are having some direction. Based on the direction only we can move around the graph. Complete graph. Complete graph means every pair of vertex in the graph must contain edges. That is, for example, let n greater than or equal to 3. Let complete graph Kn is the graph with n vertices and every pair of vertices is joined by an edge. If we are mentioning here Kn means that is complete graph. This figure represents the K5 because we are having 5 vertex. In each vertex we are having, between each pair of vertex we are having exactly one edge. So this type of graph is called complete graph. Next one is connected graph. Connected graph, a graph is connected if every pair of vertices can be connected by a path. Each connected subgraph of a non-connected G is called a component of G. Component of G. So the graph containing many non-connected graph is called the component of G. In future slides we will have one theorem. In that also we will look into that non-connected graphs, that is component, we will see on the slides. Another one is adjacency matrix. So adjacency matrix means Aij equal to 1 or 0. If its edge of G is between that vertex means we can say 1, otherwise we have to say 0. For example, in this graph we are having A to B, A to B we are having 1, but we doesn't have A to A. So that's why we are mentioning here the first element is 0 here. A to B is there, so we can give 1. A to C is there, so we can give 1. A to D is there, so we can give 1. Like the same way for the second row. B to B is not there, so we are mentioning the second row, second element as 0. B to A is there, so 1. B to C is there, 1. B to D not there, so we are giving there 0. Like the same way we can complete our third row and fourth row. So this is the adjacency matrix for the simple graph. Next one is incident matrix, that is label rows with vertices, label column with edges. So we have to look into vertex versus edges means, that is incident matrix. If you are looking to edges, vertex versus vertex means, that is adjacency matrix. Vertex versus edges means, that is incidence matrix. So in this first left side we are writing V, W, X, Y as are all the name of vertices. E, F, G, H, J are all the name of edges. So we can write V1 to E is there, V to F is there, V to G not there, V to H not there, V to J not there. So not there means we can give their zeros. If they are incident by the vertex means we can give their 1. So likewise we have to complete this incident matrix, that is vertex versus edges. Next one is path and cycle. A path of length n is a sequence of n plus 1 vertices and n consecutive edges. That is, if you want to create a path for the graph means, that is the alternative sequence of vertex and edges, we will have n plus 1 vertex and n edges. Like the same way cycle means, a cycle is a path begins and ends at the same vertex. We all know if we are having any path now, we doesn't mean to complete at the same started point. But the cycle means always cycle is the rotation one, so always have to start and ends with the same vertex. So these are all the things, path and cycle. In this graph we are having path 7. See 1, 2, 3, 4, 5, 6, 7. 7 edges we are having. So length of the path is 7. For the next graph we are having 9 edges. So we can say this is the cycle of length 9. Next one is Eulerian cycle. Eulerian cycle means we should know one thing. Always we will look into edges alone. That in the graph if we are having number of edges means all the edges should occur only once. So this is called Eulerian cycle. An Eulerian cycle in a graph G is a simple cycle that passes through every edge of G only once. Next one is degree of vertex. So degree of vertex means for the each vertex, how many edges are incidenting with the same vertex is nothing but degree of vertex. See, for this example, for the vertex A, the degree of vertex is 4 because 4 edges are incident with that same vertex. Like the same way, degree of B is 3, degree of C is 4, degree of D is 6, degree of E is 4, degree of F is 4, degree of G is 3. Next one is handshaking theorem. This is the important theorem, that is, if G is a graph with m edges and n vertices, v1, v2, etc. v1, then we can say summation of degree of vertex equal to 2 into edges. That meaning is, from the graph, if we are having total number of degree of vertex is equal to 2 into edges. That is the theorem. In particular, the sum of the degree of all the vertices of a graph is even. Next one is Hamiltonian cycle. Already we have seen Eulerian cycle. So Eulerian cycle means we have to look into edges. Hamiltonian cycle means we have to look into vertex alone. To visit every vertex of a graph G only once by a simple cycle. Such a cycle is called a Hamiltonian cycle. If a connected graph G has a Hamiltonian cycle, G is called a Hamiltonian graph. Thank you.